Hello again. The sharkC64 compiler was recently extended with an internal linker. This is the story behind that. Up to now, the sharkC64 compiler had a single-pass bytecode generator. So when the source code was parsed, bound and translated to the intermediate representation language, the bytecode was generated in the exact same order. This approach is fine if the memory model is linear, like in the picture. Then the program memory is all equal and non-specialized. Code and data segments can coexist and they can be mixed. However, this illusion breaks down as soon as you start working with the graphical features of the Commodore64. The video chip of the Commodore64 can access only 16 kilobyte segments. By default, the video segment is at the beginning of the memory, so it overlaps directly with the program memory. You can change the video segment, but even so, it will overlap with the program memory. Suddenly, the program memory is no longer equal and non-specialized. Some parts of it must be reserved for the sprites and bitmap graphics, and the rest of the program must flow around these reserved areas. This is bad news for single-pass bytecode generation, especially for the sharkC64 language, as it is modular and any of the modules could introduce graphical elements. The compiler simply cannot predict ahead of time what areas of the program memory should be reserved. This is the reason why a linker was introduced to the sharkC64 compiler. The purpose of the linker is to allocate memory for the program fragments and to update memory references accordingly. So when the sharkC64 compiler has parsed, bound and translated a program, it now produces bytecode fragments. The bytecode fragments are then passed to the linker. It analyzes which fragments use static addresses and which fragments can be relocated dynamically. So the linker first allocates fragments with static addresses. After that, it relocates the remaining fragments, starting with the biggest fragment. If all goes well, the bytecode fragments fit into the memory without overlapping. After that, the linker updates all dynamic references in the fragments based on their new locations. So now that the linker has been added to the compiler, the processing chain has 6 distinct steps: a lexer, a parser, a binder, a translator, a generator, and a linker. The lexer groups source code characters into a sequence of tokens. The parser builds a syntax tree from the sequence of tokens. The binder builds an object graph from the syntax tree. The translator turns the object graph into a program fragment. The generator produces a bytecode fragment from the program fragment. And lastly, the linker allocates and relocates all the bytecode fragments to form the final program bytecode. So that is how the new linker works in the sharkC64 compiler. Next, I'm going to add a data section to the language. It will enable inclusion of data with static addresses. Anyhow, thanks for stopping by and see you soon!